Okay, so we just multiplied some matrices for the first time and saw that it's really weird. And so I think that this example here, this application one, will kind of show you why it's defined the way that it is. Okay, so two softball teams submit equipment lists to their sponsors. You got a women's team, you got a men's team, and they need bats, they need balls, they need gloves. That makes sense. That's what softball teams need. Okay. So if a bat costs $21, a ball costs $4, and a glove costs $30, use matrices to find the total cost of equipment for each team. Okay, so before we turn this into a matrix problem, let's just do the women's team. Like if I didn't even think of it a matrix, how would I do it? Okay, so let me just multiply numbers together. For example, I need 12 bats, and each of the bats costs $21. So I'd be multiplying 12 times 21, right? And then I need 45 balls, and each of those balls costs $4, so I'm just going to multiply that times 4. And then for gloves, I need 15, and they're $30 each, right? And then I would just add up all of those products. So let me go ahead and open up the calculator so we can get a number here, right? Right. Alright, so pulling up the calculator, here we go. Of course, turn the thing on, that'd be helpful. I'm just going to do...
Clear, we need to see that. 12 times 21 plus 45 times 4 plus 15 times 30. And so the total cost for all the women's equipment should be $882.
Okay, that's what I see from the calculator. $882. My pen. 882. Okay, so and then I would do the men's team exactly the same way. Okay, so now let's look at this in terms of it being matrix multiplication. So the array of numbers as I see it in the table, I'm going to keep exactly the same. So the top row is going to be the women's team, the bottom row is going to be the men's team, and then each of the columns we have bats, balls, and gloves. Okay, and then I'm going to take that and I'm going to multiply it by a matrix made up of just one column, 21, 4, 30. Those numbers correspond to 21 was the cost of the bats, 4 was the cost of the balls, and 30 was the cost of the gloves. Okay, so let's go ahead and multiply these matrices together and see what happens. So before I do that, of course, I see that this is a 2 by 3. It's a 2 by 3, and this one is a 3 by 1. The numbers in the middle match up. Okay, check, and my answer is going to be a 2 by 1 matrix. All right, when I multiply two matrices together, I multiply a row times a column, right, and add up the entries. So I'm going to take the first row and multiply it times the, oh, I didn't make that quite long enough here. Here we go. I'm going to take the first row, all of this, and multiply it times the first column. Okay, when I do that, corresponding entries and then add them up, so it's going to be 12 times 21 plus 45 times 4 plus 15 times 30. Does that look familiar to you? Let me go back a slide and let's just look. That's exactly what I have in that top row whenever I was just multiplying it out, trying to figure out what the cost would be without it even being a matrix, right? Okay, so now to do the second row, let me just switch colors here to blue. I'm going to take the second row and multiply it times that first column. It's going to be 15 times 21 plus 38 times 4 plus 17 times 30. 17 times 30. And again, this is exactly what I would have gotten if I just multiplied each one of those bats, balls, and gloves by their appropriate price. Alright, so now let's get the final answer here. So we know from the top row, already put that into the calculator, it's $882. And let's get the thing for the second row.
Here. So for the second row, I've got 15 times 21 plus 38 times 4 plus 17 times 30. And that can't be right. 15, oh, because it's in 51. Second, enter. A little bit of dyslexia happening there. Should have been 15. There we go, 977.
977. This is the reason why matrix multiplication is defined the way that it is. It's from problems like this one. Okay. All right. Let's look at a couple of exercises that I'm going to have you do on your own. It'll give you practice, first of all, multiplying matrices. Second, it's going to lead you into seeing some properties of matrix multiplication. So write down matrix A, B, and C. They're all 2 by 2 matrices, which means that whenever I multiply them, a 2 by 2 multiplied by another 2 by 2, the numbers in the middle match, and my answer is going to be a 2 by 2. Okay, so we're good on the dimensions. And I want you to find the product AB, I want you to find the product BA, and then finally find the product CA. Let's do the first one together, just as you see in another example, us doing it together, and then I'll let you do the other two on your own. So let's find the product AB. So I'm going to write down the matrix again, -3, 3, 1, -2, and I'm going to multiply that times the matrix 1, 5, -3, -2. Okay, when I multiply these, it's a row times a column. I'm going to take this first row, multiply it times the first column, and add up the entries. Okay, so I'm going to go ahead and write the steps down again. -3. I know whenever you're doing these, you might add them up, multiply and add them up in your head. That's okay, but I want you to see the steps at first. So -3 times 1, and 3 times -3. So plus 3 times -3. Okay, and then I'm going to do the first row times the second column, and that's going to be a -3 times 5 plus a +3 times -2. Okay. Now I'm going to move on, change colors. How about red again? I'm going to move on to the second row, multiply it times the first column. 1 times 1 plus -2 times -3. And then move on to second row times second column. 1 times 5 plus -2 times -2. And again, whenever you write it out like this, before you simplify, you can see how everything matches up, and it'll help you write down the product correctly. Okay, so here I've got a -3 plus, or actually -9, that's a -12. Okay, and on the second entry, -15 plus a -6, there's -21. Okay, down here I got a 1 plus 6, so that's a 7. And then for the final entry I got a 5 plus 4, that's a 9. Okay, so let me go back here, remind you that now I want you to pause the video and do B times A, and then also do C times A, okay? Alright, did you notice something interesting about your products, about your answers? Okay, so we did the A times the B together, and you were supposed to do B times A, and when you do, you get 2, -7, 7, -5. This might seem strange to you because B times A is not the same thing as A times B. If I look back at the previous one, you can see that those entries are completely different. Well, there was one, it looks like one number, that's 7. Hey, that 7 turned out to be the same, but everything else was different about the answers, even though they're the same matrices, just in a different order. Do you remember what that's called when you multiply two numbers? If you're going to multiply 3 times 7, that's the same thing as 7 times 3. But with matrix multiplication, it's not true. That's called commutative property. Okay, so for matrix multiplication, there's no such thing as commutative property. You switch the order, you get a different answer. Okay. Number 3, multiplying C times A. And whenever you multiply C times A, your answer is exactly the same as A. It's like I just multiplied it by the number 1. This is called an identity matrix. It's like the number 1. This is called an identity. So for example, if you multiply 5 times 1, you get 5 back. If I multiply matrix A times its identity, I get that matrix back. Okay? So here is another couple of examples for you to try. So these completely on your own. I've got 2 by 2s multiplied together, but if you look at the two examples here, what we're testing out is the distributive property. We're seeing if the distributive property still works. Commutative property for matrices didn't work, so we're going to check to see if the distributive property works. All right, check and then tell me what you got.